All right, here we go. We talked about multiplying polynomials. Everybody knew how to do that. So now we're going to talk about factoring. And factoring really hard stuff. All right, let's take you guys out for a test run. Let's see what you can do. Ooh. Ooh. Got X's, we got Y's. Crazy nonsense. Carly? Carly, it's a wonderful question. You cannot combine them because this term, and this term, they're all different. They need to match perfectly. Like these things over here need to be exactly the same. And then you can combine the numbers in the front. But otherwise, even if they look kind of similar, no go. Yep, all right. Great vocab. Yeah, that's going to be step one. Step one, go looking for that GCF. Sometimes there is no GCF. Here I think we might find one. Pull out GCF. GCF, the greatest common factor. Let's get a little vocab straight in our heads. There's two pieces of vocabulary you should have straight. Factors and multiples. Which one is the smaller? Always. Chad? Factors. Factors are always smaller. They're like, if you want to think of them, little bricks. Multiples are houses, mansions. Okay, so pull out the GCF. Take a look. So GCF, the greatest common factor. What do all three of these guys have in common? Brennan? They definitely have 3. That's true. What else? Both. All of them. Now you're thinking about like, oh, do they all have 3 in common? What could you divide all 3 of them by? Even, like, what? And why? They could all evenly be divided by 3y. All right? So now you got to get straight in your head. You can only add or subtract them when they're exactly the same. But factoring things out, they just have to have a little something in common. They don't have to match absolutely perfectly. So we pull out a 3y. What do we have left over? 4x squared, y squared, minus 5xy plus 3. True? Gemini? How did I get right over here? Okay, so ultimately, when you pull out the GCF and you put it in front like this, okay, this has to multiply whatever you put in parentheses to get back the original. So 3y times 4, 12, x squared, y squared, that's how I got that y to the third. I took one of them away. You see it? Okay, maybe this isn't even written in my notes. Since we had some trouble on this, let's do another practice problem. I'll just think one up off the top of my head. How about this one? 9x squared minus 15x. How'd you factor that one? What would you pull out? What do they both have in common? Jeff? Yeah, 3x. They both have 3x in common. This leaves a 3x over here, and this leaves a 5 over here. This is factor. John, I'm not sure. Talk to me. How else would you like to show it? You know, I don't know of any other way. If you tried, some people will try and do this, right? 3 times 3x minus 5. You know what I'm saying? You can't do that because order of operations would only be these two multiplied and that tacked on to the end. So yeah. Carly, what's up, girl? This one? Oh, and the first one maybe was too difficult. People seem to get confused. So let's scale back from it. Take a look at this, right? Forget even about the top. If you multiply those two things back together, like we just did in the beginning of our lesson, what would you get? You'd distribute it, right? So basically what you're doing is, I'm giving you the answer, like on Jeopardy. You have to find the question. Undistribute everything that's inside of it. Build this back. Shoot, Ari, what's up? What's up? Absolutely. I have also seen people do this in the past. 9x squared minus 15x, because here's the easiest way to think of it. They've done, oh, I'm gonna do this, right? Yeah. But then what takes place is they do that and they just give this as the answer. And so you've left out a really crucial piece. This does not build back to be the original. It's this. If you want to think of it this way and then stick that in front, that's totally cool. It's one way to do it. All right. You guys want to practice one more of these ones? All right, and then we're going to go on to harder ones. What's up? A factor tree? To be honest, you'd have to show that to me. I've heard it before. I've used it with numbers. I haven't used it with real complicated stuff like this. No X's? All right. All right, so let's do this. Let me think of a random one. Oh, I don't know. Easy, something that's always seen like. Sure, let's factor this. I don't know. Is there a GCF? What is a GCF? Yeah, GCF is 4. Let's pull that GCF out. If you factor out the GCF, 4 times what is 4? 4, done. That's it.
I was thinking like 4 goes, it's a great common factor, but where do you get the minus square?
Well, I mean, whatever you put down over here, Jamel, it has to multiply back to be the black.
All right, cool. So 4 times 1 is 4. And 4 times, oh, okay, 16x 4 times. But won't it be negative 16x? Oh, okay, that might.
All right, nice. Now let's keep going. Let's do D. Let's step our game up once again. We're going to step it back up to Algebra 2 Trig. Suppose I got a squared b cubed plus a b squared c. Ooh. Let me just list this off over here that this was our GCF. All right. What's our GCF? AB, right? There's our GCF right there. That's going to go out in front. Let's see. I wonder what else is left inside. AB times what is AB cubed? A squared b cubed. A b squared. Excellent, guys. Plus yeah. Oh, there's something bigger. You are correct. You are correct. There is something bigger. Steve, excellent observation. Excellent observation. We got A and we got B cubed. We got A, we got B squared. So actually the GCF is AB squared. Nice one. All right, let's see. AB squared. So then it would just be what? First plus C. Let's go E. And then how about finally stuff like this? Yeah, the GCF is definitely 2. Great observation. GCF is going to be 2. That goes into all of them. It's not x because this last term does not have an x. And then after you pull out 2, what's left over? Done. Excellent. Excellent. Sometimes this last term can also be factored again. We're going to get to that. Okay. This is the next new skill that you're going to learn. Everything you have always factored has always either been 2 terms, a binomial, or 3 terms, a trinomial, right? But on your Algebra 2 trig regents, they sometimes give you crazy stuff that looks like this, which is quadnomial. Past trinomial, people just call it a polynomial. The first thing you're going to look for is like, is there a GCF? What do you think? Do all those things have anything in common? No, absolutely not. Okay, so we're screwed on that part. The next thing you're going to do is you're going to do something called factor by grouping. Anytime you see something with 4 terms on it, always just do this. It's really, really, really easy. Factor by grouping. You're going to take these first 2 terms. Okay, so here's what you do. You take these first 2 terms, group them together. Take these second 2 terms, group them together. And from each of them, you have to decide what the greatest common factor of them is. Take a look at these first 2 terms. What's the GCF of those first 2 terms? A squared. Very nice, guys. Yeah, a squared. So pull out the GCF. When you pull out the GCF, you get a plus 1. Now, from those second 2 terms, is there something they have in common? They have 2. They also have negative 2. I'm going to pull out the negative 2 because I'm going to show you why. A plus 1. Factor by grouping works if you've done it correctly, will always result in these 2 things in parentheses matching identically. And then what you do from here, you don't cancel them away. I'm going to put funny squiggle lines. Take these 2 funny squiggle lines, these things that you pulled out, these GCFs, all right? Take the 2 GCFs, put them in one parenthesis. And take one of the other quantities and put it right next to it. What's up? Sure. In one parentheses, you have the GCFs, and in the other parentheses, you have, how would you say this? One of the other binomials. One of the identical terms. Whoops. Here, let's give you more of what you're going to see over the next coming days, right? X squared plus 7x plus 12. How are we with this? Just remember how to do this? Yeah. We got to find 2 things. First of all, is there a GCF? Is there anything these guys have in common? No. These are the easy ones, right? You got to find 2 things that multiply to be this. Multiply to be this one, add to be the 7. So we're going to put an x in front. Yeah? Give me 2 numbers that do that. Jessica? 4 and 3. That's how that one works. Doesn't matter. It doesn't matter. It doesn't matter if it's yep. That's that one. So there we go. That was easy. Let's take a look at 4. We got, we've got 3x squared, right, minus x minus 4. Uh-oh. Okay. All right. Let's go back for a minute. In my other class, we talked about adding or subtracting fractions. When you add or subtract fractions, when the bottoms are the same, that was a happy problem, right? It even looks like me. Look. Okay? Yeah, see? When you have a number in front over here that cannot be taken out, oh my God. Yeah, it's sad. It's going to require a lot of work. Brandon, your question before was excellent. You hated the problems that like you had to guess at. Okay, here's the steps. We're going to use this. This is going to be called the AC method. It can be used for every single type of factoring problem that has 3 terms or higher. The AC method. Here's what we do. Take the original one. Okay. Take the first term and the last term and multiply them together. Sometimes it's also called the barbell method because the first step looks like a barbell. Yeah? What's 3x squared times negative 4? Yeah, negative 12x squared. Multiply them together, you get negative 12x squared. Okay. Now, give me 2 numbers that multiply to be negative 12x squared, but add to be this middle term. Which one? Yeah, that really, really matters that you get that correct. So it's going to be negative 4x and positive 3x, right? They multiply to be negative 12x squared, but they add to be this middle term right here. So here's what you do, right? You take these 2 numbers, let's refresh, right? Step 1, take the first and the last term, multiply them together. Step 2, from that number, find 2 numbers that multiply to be it, but add to be the middle number of the original. Take the first 2, write them down. Don't worry, we're going to give you a sheet. I'm going to give you a sheet that has all this listed out. I just want you to see how all of it connects and links together, right? Do you see what we did? Essentially, all we really did was rewrite this middle term in terms of these 2. Now, I taught you something about 10 minutes ago, right? There are 4 terms of this sequence. What do you use next, do you think, Carly? Yeah, factor by grouping. That's how factor by grouping fits into our lesson, to our sequence. We are going to take this 4-term thing and factor it by grouping. The first 2 terms, what is the GCF of them? X, that's totally fine. We get 3x minus 4. From the second term, what's the largest thing, what's the GCF? Nope. Yeah, only 1. Sometimes that's the case. That's fine. Just positive 1. Right? Our whole goal was to get them to match. Now, what was the next step? Yep. Take these 2, put them together in 1 parentheses, the GCFs. 3x minus 4 in the other. And that's how you factor anything, no matter how hard it gets. Okay? 4x squared minus 25. Ooh. Ooh, yet another type of factor. This is a very famous example. Sometimes some teachers call them dots. Okay? Do you notice how it's only 2 terms? Yeah? Is there a GCF that you can take out of them? You're always checking to see that. No GCF that you could take out. It's only 2 terms and subtractions in between. The next thing you want to check to see if you can do is if you can do the following. If you can take a square root of this number and you can take the square root of this number, right? And they come out to be nice, it's called a dot. This is the difference of 2 squares. Okay? The difference of 2 squares always has a common pattern. You saw an example of it earlier. This is going to be 2x minus 5 and 2x plus 5. How did I know it to be 2x? Because I needed the front number to be 4, right? So it's always going to be, the numbers and things in the parentheses are always going to be the same. You'll just see the signs in between switched. Let me give you an easier example of this, Carly, right? You see this all the time in like normal algebra. Suppose I gave you this, x squared minus 9, right? What is that? If we try and factor it. Hulda, do you know? Very nice. It's x minus 3 and x plus 3. Some people just guess at it, but take a look. Here's how you can always check. Number 1, it has 2 terms. Number 2, there's subtraction in between. And number 3, do you see how there's like the numbers in the front? The square root of 1 is 1, and the square root of 9 is 3. So this is the difference of 2 perfect squares, the difference of 2 perfect square roots. That's always the pattern that you'll use. What's up? It's a great question. If there's an addition sign, you just leave it. It can't be done. It's said to be prime. But that might exist anyway. I'll change it up, right? Yeah. Suppose it's 0.25 minus 9x squared, right? 0.25 minus 9x squared. Well, let's convert this. You might not know that 0.25 is a perfect square. You may. I don't know. Let's check. What's the square root of 0.25? Problem. Square root of 0.25? How much is it? 0.2, what is it? I think it's 0.5, right? Guys, that's all I got for you today. We're going to continue on tomorrow. If you don't understand something, here's your job, right? Your homework. Look through your notes. Come in after school with a question. Or practice something that we did in class so that when you come in tomorrow, we can get into groups maybe, or work by ourselves, and get some and figure out what the hell's going on with factoring. Yeah. Yeah. What's up? The answer would be this right here.